So we're starting a new chapter in geometry, so this is all very exciting. And along with a new chapter comes some new vocab words. So let's get started. First thing is something called a plane. So the surface of a plane is the surface such that if any 2 points on the surface are connected by a line, all points of the line are also on the surface. All right, so this sounds a little bit confusing, I'm sure. A lot of times when planes get drawn, they tend to get drawn like this. Looks more like a parallelogram. So we've got 2 points on the plane joined by or connected by a line. So this point, and this line are all on this plane. I kind of think about planes as being like a two-dimensional surface. It does continue forever in all directions. So that means that this line would also continue forever in both directions on this plane. All right, so we've got plane. Now you've got something called coplanar. Coplanar sounds, or doesn't sound a lot like, but it reminds us of collinear. If you remember, collinear is when you have points that lie in the same line. Well, coplanar are points, lines, or segments that lie in the same plane. So up here, this point is coplanar with this point, and this point is also coplanar with the line. Basically, these three are all coplanar. You also have non-coplanar, so I'm sure you can guess what that means. If it's non-coplanar, that means the points, lines, or segments are not in the same plane. All right, so now we're getting to something called a transversal. We're going to be using transversal quite a bit in this chapter. A transversal is a line that intersects two coplanar lines. So now we know what coplanar is. Two lines that lie in the same plane in two distinct points. So here we have two coplanar lines. So the two coplanar lines are lines A and lines A and B. And this one that's crossing through both, it intersects A right here and it intersects B right here. That is the transversal. Now if you notice what a transversal does when it connects or when it intersects another line, we are getting angles out of that. There's 1, 2, 3, 4 angles from intersecting that line, and you have 1, 2, 3, 4 from intersecting this line as well. So we're going to do a lot with those with those angles from those intersecting lines. The rest of the examples are going to look something like this, where you've got your two coplanar lines and your transversal cutting through. And those 8 angles that I mentioned they're classified as certain types of angles. So we're going to go through what those are. First, you've got alternate interior angles. Alternate interior angles are angles on the interior and on alternate sides of the transversal with different vertices. So what we're talking about is the interior of our two coplanar lines. The interior is going to be what's in between or inside of these two lines. So we're talking this area here and this area here. That's all the interior. So angles 1 and angles 2 are alternate interior angles. If you notice, they are on the interior of your coplanar lines, and this is our transversal cutting through. They are on the opposite or alternate sides of that transversal. So you see this one kind of looks like it's on the right, and that one looks like it's on the left. So we can say that angle 1 and angle 2 are alternate interior, and we can abbreviate that with AI. They are alternate interior angles. If I were to fill in the other two interior angles 3 and 4, we could say that angle 3 and angle 4 are also alternate interior angles. They are on the interior of our coplanar lines and alternate sides. One's on the left, one's on the right. So alternate interior angles. And then another thing to point out, if you take a look at angles 2 and 4 right here, do you see how we've got this straight line and angles 2 and 4 make up the two angles for that straight line? So angles 2 and angle 4 are supplementary angles. Which makes them a linear pair. And we could say the same thing about angles 1 and 3 as well. So that's your alternate interior angles. Now let's take a look at alternate exterior angles. So alternate exterior angles are angles on the exterior and on alternate sides of the transversal with different vertices. So again, here we have our transversal cutting through these two coplanar lines. So the exterior part of this is going to be on the outside of those two lines. So this is all exterior and this is all exterior. If you notice, angles 3 and 4 are on the exterior, the outside of the two lines. And then we've got our transversal cutting through, and they are on opposite sides or alternate sides of that. So angle 3 is on the right, angle 4 is on the left. So we would say that angles 3 and angles 4 are alternate exterior angles, and we can abbreviate with AE. And again, if I were to fill in, let's say this is angle 1 and angle 2, angles 1 and 2 are also alternate interior. And hopefully you caught that I said the wrong word. That's supposed to be alternate exterior. And then we do have those supplementary angles again. Angles 1 and 3 are supplementary, and angles 4 and 2 are supplementary. So that makes angle 1 and angle 3 a linear pair. And also angle 4 and angle 2 is a linear pair. So we've got alternate interior and alternate exterior angles. So just a couple more vocab words for our intro video. We've got corresponding angles. So corresponding angles are angles that are on the same side of the transversal, so they're not going to be on alternate sides like the last two, but one is on the interior and one is on the exterior. So if you take a look at our picture right here, you've got that transversal cutting through again. I'll abbreviate transversal. Here are two coplanar lines, and then angle 5, now is that an interior or exterior? That's interior because it's in between your two lines, and then angle 6 is exterior. And do you see how they're on the same side? They're both on the right side of that transversal. So that means that they are corresponding angles. So we would say angle 5 and angle 6 are corresponding. We can abbreviate it like that. And then let's just go a step further. Let's say this is angle 4 and that's angle 7. We could talk about angles 4 and 6. Anyone know what we would call angles 4 and 6? So when you have two angles that are formed by intersecting lines and are across from each other like that, we've learned this before, angles 4 and 6 are vertical angles. And how about angles 4 and 7? These two supplementary angles, you would call those a linear pair. So lots of vocab to throw out here. All right, last part of our intro video, we've got parallel lines. We know about parallel lines. You guys, I'm sure, could tell me lots about them, but in a geometry class, let's get a little bit more specific. Parallel lines are two coplanar lines that never intersect. So if you look at this first example, we've got line A and line B. These look parallel to me, but we cannot assume parallel lines. We can't assume parallel lines. in order for us to know that they're parallel, kind of like your 90 degree, if I were to draw this, I can't assume that it's 90 degrees unless I have that little box in there. So for parallel lines, what you have is a little, it's like an extra arrow top or arrowhead or whatever we would call that. So that's how we show parallel lines in math. And we would say line A is parallel to line B. It kind of looks like we drew those parallel lines in between them. All right, so our next picture, let's say we can see that probably these are our two parallel lines, right? So we would have to have our little arrows, but you also, sometimes you'll see two sets of arrows like that. So if these were all in the same figure, we would know that A and B were parallel to each other because they each had one little arrowhead, and EF and GH were parallel. We can write that down. EF is parallel to GH. Kind of like the way we pair up our congruencies. The two lines, or the two arrowheads, will be parallel to each other. All right, and then the last one, this is what a lot of our pictures are going to look like. Two coplanar lines with a transversal cutting through. So that's your transversal. And then for us to say that these lines are parallel, you would have to have those little arrows on there, and we would say X is parallel to Y.